Hey everyone, and welcome to my talk on the autonomy of credential stuffing attacks. I'm Jamie Hughes, one of the lead solution engineers here at Auth0. For those that don't know, Auth0 is an identity as a service platform founded in 2013, and today we handle over 4 billion logins every month for roughly 9,000 customers across the globe. Without going into all the detail, we make authentication and authorization easy to implement, and since handling authentication is our daily business, we obviously deal with credential stuffing attacks fairly often. So a brief agenda for today. So I'm going to quickly cover a definition and introduction to what credential stuffing attacks are. We're then going to look at some of the key enablers which makes credential stuffing attacks possible and very lucrative for these attackers. I'll then quickly talk about some of the business impacts for organizations who fall victim. And then we'll finish off with ways to actually, look at ways to actually mitigate and understand that you're actually under one of these attacks. So what is a credential stuffing attack? So 2 words, credential stuffing. So when I talk about credentials, it's the username, email, and password combinations that we use as users to gain access to our online accounts. So the claim piece, made up of 2 bits here: claim and proof. So the claim piece is being our email and username, and the actual proof, is our password. It's a secret that only we're meant to use or know. Sorry. And we use that to gain access to our online account, the combination of both. And then the stuffing part, I basically mean, mass testing, mass requests. This is a type of cybersecurity attack, very, very popular in the industry at the moment. And it's where attackers are using these credentials, and I'll talk about where these credentials come from in a second, using these combinations in large-scale automated attacks to try and gain access to user accounts for a particular service, a particular organization. So what are the processing components involved? So there's billions of these leaked credentials out there. So as we've gone across many years, there's been many data breaches where email and password combinations and passwords in plain text have unfortunately been leaked. Organizations have fell victim to these data breaches. So it means, us as end users, our data unfortunately has been exposed in one of these data breaches. So there's numerous databases out there where these breach lists are available. So this is kind of the main thing that the attackers will use in their attack. And then we look at how they make these requests. So this is where we look at kind of botnets, automated attacks, automated scripts, where they then inject these credentials as the main parameter of these attacks. And as I said, they're particularly targeting an organization's login flow. And typically, actually, attackers will target multiple organizations at any one time using these breach lists. So these are breach lists that have been breached from another website, and they're then hoping that they'll have some success of gaining what they call unauthorized access to a user account on that service, in the hope that the user's reusing the same credentials on that service. So they'll continue to perform this attack, typically over maybe a short or a longer period of time. More sophisticated attacks tend to go on for a longer period of time, as they only send a very small number of requests in a certain time frame to kind of go under velocity-based attacks. And the attackers will be monitoring this for successful logins. And then once there is a successful login, they'll actually scrape that account and understand what value is attached to that account. So typically when we talk about this, we're looking at accounts which have a value attached. So maybe it's a subscription service, so media, publications. Potentially it's a loyalty service where the user's gaining loyalty points, or potentially, it's a finance credit system such as PayPal, for example. And then the attackers, once they've got, once they've had success with these, they've found accounts that they've managed to compromise and commit account fraud, they'll then package these up and sell these on a marketplace on the dark net. So there's obviously a demand for this. Users are wanting to pay less than the market value for these accounts, and therefore that's exactly what they're trying to do. So we hear about this in the news all the time. As I said, it's very, very common at the moment. Had a UK supermarket had to suspend 620,000 of their loyalty scheme accounts after they confirmed that stolen password and email combinations were used to breach these accounts. So impact to the business was they had to reimburse all of those customers that had actually been had their loyalty points drained from their account, reissue them with new loyalty account schemes, and the users had to reset their password. Got a global media streaming company who actually denies any kind of security breach or credential stuffing attack, but the only possible reason for this was a credential stuffing attack that basically compromised their users, because a week after their global launch, there was thousands of their user accounts that were then being sold on a darknet marketplace. And then again, another UK retailer in March this year had to suspend their entire loyalty point scheme online and in store whilst they resolved this issue. And they did actually again confirm that none of their own systems were compromised, but attackers had gain unauthorized access to their users, their customers, by using combinations of passwords and emails that were breached from a different website. So let's look at some of the key enablers for credential stuffing attacks. How are these possible? So the first one is the fact that, us as a user, we're still very reliant on organizations that are unfortunately only providing a single factor username and password authentication into websites. So as I log into a site, I'm only required to provide my email address and password. And I've got an article here from CNET in 2004, quotes Bill Gates saying at an RSA conference, "There is no doubt that over time, people are going to rely less and less on passwords." Well, now it's 2020, 16 years later, and it doesn't really look like things have changed that much. Me as a user, for a good majority of my consumer applications that I use, I'm still only asked for email and password authentication. Sure, multi-factor is available across the majority of those services, but it's still only an optional extra that I can add to my account. It's not being forced upon me. So again, a less security conscious user who doesn't want to add friction to their online user experience may not go and enable MFA, leaving their account exposed to just this single username and password factor. You've then got these breach credentials lists that I talked about. They're out there in the number of billions. You've got different tools like this one here, for example, called Have I Been Pwned, who keeps a record of all of the data breaches where credentials have been exposed. So you can actually type in your email address and understand if that email address has belonged to a data breach. It will tell you which site and also the date of the breach as well. But then in terms of the actual forum here for attackers, there's a lot of these kind of databases and forums available on the darknet. So this one here called RAID forums, they offer around 7 billion records across 370 different databases. Some of these are free, and obviously in the free ones, you may have slightly more out-of-date data, less reliable, less lower success rate. Whereas the paid databases where they can download for a fee, there may be more reliable credentials, higher success rate, and therefore typically they'll go for one of those, kind of invest in the attack, if you will. So, how do these credentials actually get leaked in the first place? How do these breach lists exist? Well, one way which was very popular for Windows environments was the use of Trojans, malware. User would accidentally download some form of attachment or something from a website which would install something on their machine, such as a keylogger, or take screenshots. And then as the user's actually authenticating on their machine into desktop software or web-based applications, it will actually then capture their credentials and add them to one of these breach lists. You've then got your standard phishing attack. So, tricking you onto a website that isn't actually the genuine website. These emails are usually, branded. This one here, for example, is a PayPal example. They usually put some kind of message in the email for some kind of amazing offer or create some kind of urgency. So, a less security conscious user in panic to this or in excitement to this, they quickly click the link in the email. They're redirected to a fake website. They provide their credentials on this fake website. And then the attacker, on the back end of this, is actually just capturing their credentials for whatever service and adding that again to a breach database. You've then got the last one here, which is where organizations actually fail to have the correct security measures in place. So an attacker is actually able to go via the back door and breach the server directly. So whether that's gaining root access to a database, tricking the database with a SQL injection, for example, or even easier than that, organizations who don't have the right security permissions set on their databases, on their S3 buckets. There was a very prominent example in 2019 where an organization had all of their PII data for some reason stored in an S3 bucket, and it had public permissions. So the attacker was very easily just able to download that database and gain access to all of that user data. Password reuse being the next one. We as users, we're a key enabler of this. Study from Shape Security here, the average user has 26 online accounts. This increases to 40 when the age demographic is lower. The average user apparently has roughly 5 passwords that they reuse, which means they're reusing this password anywhere between 5 to 8 different sites. You know, us as, you know, me as a more security conscious user, you know, I use a password manager to generate a secure random password for any of these online services I'm using. But again, a less security user who's not aware of these typical tools will just reuse, you know, a password they can easily remember across these sites, you know, making them again very vulnerable to these types of attacks. Attack tool availability. So, you know, sure, you know, the attacker can build this script themselves. They can, you know, use developer tools in a browser to understand the login endpoint for an organization and build these scripts themselves, but they don't need to. It's all available in a marketplace. There's plenty of examples on these darknet forums where these attackers can simply buy a pre-configured automated script botnet, which is specifically already been designed to target a particular service. Again, some of these are free, some of these are paid, you know, being the more reliable ones. And you can see here in the screenshot some really kind of key names here where these attack tools are available. You know, and if we go into this Adobe example here, you know, this one allows a really sophisticated attack. It allows you to inject multiple breach lists as the parameter, so it will try, you know, multiple credentials. It allows you to set the number of threads. It allows you to put delays in between requests. You know, it allows you to load a list of proxies in, so the attacker has access to thousands of rotating IP addresses from you know, many regions. And in this case, this one will even scrape the account, so it will monitor the attack. It will, you know, alert you when it's actually managed to breach an account, and then it will also attach the associated value to that as well. So it really is, you know, available an end-to-end solution here. You've then got the ability for the attackers to source, you know, thousands of IP addresses now, for, again, very cheaply on the darknet. You know, they can buy, you know, here, for example, 1,000, you know, global IP addresses for just less than $10 a month. Obviously, the more you want to pay, the larger list of, you know, IP addresses you get. You can also get free IP addresses as well, but they tend to have a much, you know, less well-known reputation. They belong to blacklists, typically from regions where you associate kind of malicious traffic. Whereas, you know, the higher value packages here tend to be, you know, more reliable IP addresses, and also from kind of, yeah, maybe locations such as the US or European countries. And believe it or not, users that actually out there that use these free VPN tools, what they're not actually aware of is that these kind of sister darknet proxy list marketplaces are actually stealing their bandwidth and being able to steal their residential IP addresses and then package them up and sell them to these attackers. So attackers are actually able to use, you know, reputable residential IP addresses by these users are using these cheap free VPN tools out there. You've then got captures, so capture solvers. So I'm sure we're all familiar with using captures, completing captures, and sign up login flows. It's a defense mechanism to actually prevent against these scripted and bot attacks, such as credential stuffing attacks. But again, there's plenty of services out there that offer these services, you know, these solving services very cheaply. Some of these are OCR based, so just basic image recognition. But other of these, you know, services provide an API, so the attackers can actually build these solving services into their attack. And on the other end of this is actually real users that are sitting there solving these captures in real time. Browser fingerprint switches as well. So similar to IP address, when I talk about browser fingerprint or user agent string, is characteristics specific to your browser. So it's a header that contains information about your browser and your operating system that's used in web requests, when we make web requests for online. So, you know, me and you as a user, if we're using both using Google Chrome, both using a MacBook, for example, and visiting the same website, that browser fingerprint will actually identify that we are two completely separate users. But again, you know, some organizations are doing velocity-based defenses on these on browser fingerprints. So the attacker will need to switch up their browser fingerprints that they're using. But again, not a problem. They can go to a darknet marketplace and they can download thousands of browser fingerprints for a small cost, and then inject these again into their attack to keep on switching the fingerprint that's being used, very similar to the IP address. And then the last enabler here, sorry, is the marketplace availability. So very like we use, you know, day to day, and we use services like Amazon or eBay or Etsy to purchase, you know, items that marketplace sellers are selling to us. Well, the attackers can do this on the darknet. There's readily available marketplaces where they can brand their shop. They can upload these stolen accounts, sell them for a particular value, And there's also payment gateways as well. So they don't even have to worry about, providing a way for their users to pay for these. It's all there ready to go as a service. So you can see from what I've shown you today, it's like an end-to-end solution, attack as a service, marketplace as a service. So very, very easy for attackers to perform these attacks. Just very quickly on business impacts. So, organizations that fall victim to these. So you've obviously got reputation, negative PR, loss of user trust, users no longer feel comfortable using your service, storing PII, which then can lead to a loss of revenue via churn. Users choose to use a competitive service who maybe haven't had a data breach or fallen victim to one of these attacks. You've then only got any downtime that's associated. I talked around the UK retailers at the start actually have to suspend their loyalty systems for a period of time. You've also then got the increased operational costs, users that realizing something's not right with their account, they call your support center in mass. And you've also got the computational cost of actually handling these requests. So these credential stuffing attacks, right, they're requested in the millions. And if you haven't got the right defenses in place to actually, first level defenses, you actually have to process all of these login requests. And obviously that can massively increase your computational cost of handling those requests. And then the final one here is GDPR, data privacy regulations, regional privacy laws. If the attackers manages to steal, a lot of PII data for your users, then again, these organizations can be subject to large fines imposed by these data regulatory bodies. So final topic here, mitigation. How can organizations actually mitigate these attacks? So just very quickly here at Auth0, as I said, this is our daily business. We see 4 billion successful logins a month, but the total traffic is much higher than that. I think we have around 150 million login requests per day. And at any one point, we recognize up to 67% of traffic going through Auth0 as being suspicious. So as I said, a very key industry problem at the moment. So how do you know there's an ongoing attack? Well, you have to do by looking at your login traffic. So it's always a good idea to benchmark your normal traffic patterns, and also for spikes as well, where you're anticipating maybe sales or periods where you would expect higher volumes of traffic. Benchmarking that and then being able to easily identify when you may be kind of under some form of attack. And as we can see in the chart here, all of a sudden on one day there was a huge increase in failed username and password events. So in this scenario, it was very, very easy to understand that something wasn't right. There was a huge amount of increase in requests, and therefore identify that this is likely a credential stuffing attack. In this example here, an attacker was able to gain, a very sophisticated attack here, gain a large access to a number of unique IP addresses. They were actually using 38,000 different unique IP addresses from the US region. So this is showing, particularly here again, it's showing a number of unique IP addresses which were used in failed username and password events. And you can see towards the end of the chart here from the 8th of April that actually the attacker again started to switch it up. They gained access to more unique IP addresses. They switched the regions again to try and go under those under the radar. And this one here, just quickly looking at how attackers might start these attacks. So you can see here on the around the 3rd of March, the attacker did an initial test run. This red traffic here, as you can see, is 401 events. It's unauthorized events, so it's failed username and password. You can actually see down here that there's actually, believe it or not, some green traffic, some green charts, which shows their normal traffic patterns. So you can see all of a sudden very abnormal levels of traffic. And this was basically, the attacker running the attack over a period of time lasting a couple of days. So again, typical to look out for that initial test run. You have all of a sudden you have this increase of traffic that's then spiked and then stopped. Is that attacker just testing their script and then they're getting ready to really attack you, within a couple of hours, within maybe a couple of days? So, real protection requires defense in depth. If you've been around in security, you'll have heard that term before, defense in depth. It's basically a security concept which you protect systems through multiple layers of security. So specifically when we talk about credential stuffing attacks, we're looking at bot detection. First level of defense, actually stop you actually processing these login requests. So you're not even validating the email and password combinations, you're blocking that request up front. And you can do that based on some of the stuff that I've talked today, which is looking at IP reputation, is the IP address belong to a blacklist? Does the browser fingerprint belong to a blacklist? And therefore not even process the request, maybe insert a capture into that login flow to prevent first defense then. You've then got velocity-based defenses, looking at the number of IP addresses that are being used, number of browser fingerprints, having some form of breach password defense in place. So obviously all of these databases I mentioned that are available there, which contains these billions of records of leaked data, actually having your own database or your own service, which you call, to query to see if a user is actually using these compromised credentials. And therefore, if they are, you can actually block them from logging into your service, or maybe then do an MFA challenge, a multi-factor challenge. So the key defense here to protect your end users from falling victim to account fraud is to implement multi-factor authentication. So even if the attacker does get the first factor right, they manage to gain access get the first factor correct with the email and password combination, then they cannot complete the multi-factor step, because potentially they don't have access to the SMS number, they don't have access to the phone, which has got Google Authenticator or the push-based notification available on maybe their security key. Again, security conscious using something like a YubiKey, for example. So these are the real defenses that organizations should have in place, the multiple layers to protect against these attacks. And that's all I've got for you today. Thank you very much for your time. I hope you found that useful. Thank you.